Welcome dear friends. Today we will discuss about poison and antidote. In your examination, question will be asked in this manner. Explain antidotes. Write types of antidotes with examples. Write preparation, properties, assay and uses of sodium thiosulfate. So in that question you will explain antidotes. You will write the various types of antidotes with their examples, and you will mention the preparation, properties, assay and use of sodium thiosulfate. So now first we will discuss about poison. Poisons are the toxic chemical substances that is harmful to our body. So the harmful chemical substances which are toxic to our body are known as poison. Antidote. Antidotes are the substances that react against ingested poison or toxic substances or overdose of any potent drug and will nullify its side effect. So this is the definition of antidote, that will react against the poison and nullify its side effect. What these antidote do? These antidote neutralize the poison or its toxic effect, or they act pharmaceutically, that is the antagonism action, or by chemically, that is formation of chelates or acid or any chemical derivatives, and they will convert the poison into non-toxic or less toxic compound, so that the antidote can act by either of these three. Now, based on the mechanism of action, these antidotes can be classified into three different classes. First one is physiological antidote, second is chemical antidote, and third one is mechanical antidote. First one, physiological antidote. This physiological antidote gives effect opposite to that of poison, or they physiologically counteract the effect of poison. Example is sodium nitrite. The sodium nitrite gives its effect opposite to poison and nullify its side effect. Second is chemical antidote. These chemical antidotes combined with the poison and changes the poisonous nature of the toxic substances and nullify the effect of that poison. Example is dimercaprol, dimercaptosuccinic acid, ethylene diamine tetraacetic acid, that is EDTA. So these are the chemical antidote. They will combine with the toxic substances and will change the poisonous nature of that toxic substances. Third one is mechanical antidote. This mechanical antidote can prevent absorption of poison in the body, or they expel the poison out of the body by emesis process, or they eliminate the poison through the urine. So this mechanical antidote can act by either of these three. Either they prevent the absorption of the poison in the body, or they expel the poison by emesis, or they eliminate the poison through the urine. Example is activated charcoal. Now sodium thiosulfate, its preparation, properties, assay and use. First is properties. It exists as a white crystalline solid powder. It is odorless. It is highly water soluble. pH of 1% solution of sodium thiosulfate, it is in between 6 to 8.4. Molecular weight of sodium thiosulfate is 158.11 gram per mole, and density is 1.667 gram per cm cube. So these are the properties of sodium thiosulfate. Next is preparation. This sodium thiosulfate can be prepared by treatment between sodium hydroxide and sulfur in the heating condition. So in the heating condition, whenever 6 mole of sodium hydroxide react with 4 moles of sulfur, 1 mole of sodium thiosulfate will be formed with the formation of 2 moles of sodium sulfide and 3 moles of water. This sodium thiosulfate can also be prepared by treatment between sodium sulfite and sulfur in the heating condition. So in the heating condition, whenever sodium sulfide, that is Na2SO3, react with the sulfur, then sodium thiosulfate Na2S2O3 will be formed. Next is assay. Assay of sodium thiosulfate is based on iodimetry titration, because the solution of sodium thiosulfate is titrated directly with the standard iodine solution using starch as an indicator. So this kind of titration, in which the analyte that is sodium thiosulfate, that is titrated directly with the standard iodine solution, that is known as iodimetry titration. Procedure is: take 0.8 gram sodium thiosulfate powder and dissolve in 30 ml distilled water in the conical flask. Titrate this entire solution with 0.1 normal standard iodine solution. Add 3 ml starch solution as an indicator towards the end point. This end point can be detected by discharge of yellow color of iodine. So this solution of yellow color will become colorless. Factor is: each ml of 0.1 normal iodine is equivalent to 0.02482 gram of sodium thiosulfate. Sodium thiosulfate 2 mole that react with iodine, that gives Na2S4O6, that is sodium tetrathionate, and 2 moles of sodium iodide. So this is the assay of sodium thiosulfate. Uses: the sodium thiosulfate, it is used in the treatment of cyanide poisoning. It is reducing agent. It is standard titrant in iodimetric analysis. Storage: it should be stored in tightly closed container. So this is all about antidotes and monograph of sodium thiosulfate. Whenever question asked in your examination, you will mention all the things. Prepare well. We will meet again in the next lecture with the another topic. Thank you for watching this video.